Hello. Today we're going to be talking about curl, which is one of my favorite command line tools. It's something I use a lot, and we're going to talk about how to make HTTP requests with it. So curl is a command line tool. It makes HTTP requests. That's what we just said. And one good thing about it is that it exists on Linux, it's on Mac and BSD, it's on Windows, so it's basically on all the platforms, which is really useful. Another good thing about it is that it can make basically any HTTP request you want. So if your browser can make like a GET request or a POST request or whatever, curl can make the same one. So it's really powerful in that way. And it lets you sort of like play around with these things on the command line if you want to. And the other great thing about curl is that it's usually already installed on Unix systems. So often, like if you're on a random server somewhere that maybe doesn't have that many things installed, curl is always there. There are other tools that make HTTP requests. There's this really nice one called HTTP IE, which you can get with like a pip install. And the way you use it is like you can do HTTP get like some URL, and then it'll show you the whole response. It'll syntax highlight it. It'll show you all the headers and like highlight those. It's really cool. I think that's a great tool too. But what I like about curl is that it's really everywhere. It's always installed. Lots of examples on the internet use it. And so it's what I prefer just because it's more like the default. And I've used it a lot, so I'm kind of used to it. So that's what this video is going to be about. So you might be wondering, like, why do I need to make HTTP requests, right? Like, what's the point of having a command line tool to do this? So I'm going to talk about the three like top reasons I end up using curl, which are to prototype like an API client I'm working for if I'm trying to write some code that uses some API. The second thing is to look at HTTP headers for like some website that maybe it's my website and I want to make sure that the headers are set correctly because I'm trying to debug something. And the third thing is sometimes to install software. And I found these basically by looking through my like shell history to be like, how have I used curl in the last like year? And yeah, these are the big things. So let's just start out by doing some examples. So the basic thing that curl does is if you do like curl and go to some like URL, like example cat.com /cat.text, which is just like some site, it'll show you like this like little ASCII cat, which is really cute. So this cat is basically the response body of this URL. And so curl just prints out the response body to standard out. Another example is, I know that like at wizardsnews.com /pages.atom, there's this RSS feed. And recently I was looking at this a lot just because I wrote this RSS feed. Like I'd written some code to generate it. And I wanted to make sure that I'd done the right thing. So I can just curl that, it prints it standard out, and then I can pipe it to less. And then it'll just show me the output. And then I can kind of look through and be like, okay, is this the right thing? Is like the publish date right? Is it what I expect? So I do this a lot, is I just like curl some website, pipe it to less, and make sure that like the HTML or the XML or whatever of the code that I wrote is what I expect. And I find it sometimes faster to do it that way than doing it in the browser because there's less clicking, right? It's nice. Okay, let's talk about a couple of other examples. I said that I like to use curl to look at headers, so let's do that. So one example of looking at headers is we can actually look at this same page, like pages.atom, but instead just look at the headers. So normally what curl does by default is it'll make a GET request. But an alternative to GET request, if you just want to see the headers, is you can make something called a head request, which is like, hey, make a GET request, but just like it's as if it's a GET request, except it only shows you the response headers. It only will send the response headers back. So -I does that, and then I can just see the response headers, and in this case, it's like, oh, this is served from Netlify, right, which is like the CDN that I happen to be using to serve this site. You can see there's like a request ID, which really, like, who cares? You can see the content type, which is like application/atom plus XML. It can be important to check this because if you're serving the wrong content type for some reason, the browser won't display it correctly. So if I were maybe debugging like a display issue with this page, I would look at the content type header. So there are a bunch of useful things to see here. We can look at like one more site's header, which is, let's say, we can look at like my blog, jevons.ca, ca, and then here we can see like the server's Cloudflare, which is, I know, is the CDN that it's using. We could go look at like github.com and see how they serve their site. So I think they have this like complicated content security policy that they've set here on their site to help keep you secure, which is good. And I guess they're not really using a CDN. You can see some cookies that GitHub is setting, and that they're saying like not to cache the page. Yeah. So that's looking at headers. That's really useful and really easy. Let's see what else we do. Oh yeah, I wanted to talk briefly about about installing software, because often if you go to a site like especially on Linux, I think on a Mac they're maybe a little more likely to ask you to like just download something, like a signed binary, or on Windows it's more likely to be like download this thing, and like double click on something. But on Linux, if you're downloading something, it'll often be like, oh, like download this thing with curl, and then like put it here. So YouTube DL is this great piece of software that I just needed to reinstall, and it'll download YouTube videos and also videos from other sites. It's amazing. It's great if you want to if you have a YouTube video you want to watch it offline later. It basically always works. It's incredible. Anyway, so the way that you can install it on Linux is you just like, hey, curl this thing, output it to /user/local/bin, and then I just needed to change the permissions on this so that it's executable. When I install software with curl, I always try to make sure that it's a site that I trust. Like I know that this is YouTube DL's site, and I always try to make sure that it's also using HTTPS, because I don't want to be downloading like random things putting it on my computer. And then the other thing that you sometimes see with curl is here it's downloading this public key, and we can actually do that really quick and just see like what it's getting. So this is some kind of PGP public key for some apt repository that I wanted to add because I need to install some software. So there it is, and then it just pipes it to apt key add, so that I trust it. And this is again like I ran this from some website that I trusted, right, to not do something bad. And then the last kind of like more complicated thing that we're going to talk about with curl is to like test out an API, right? And so like let's say I want to use the Pinboard API. I think this is something that I actually ran in like 2017 when I wanted to look at the Pinboard API for some reason. Pinboard is just like this bookmarking site. And so there's kind of a couple of things that you have to do when you're working with an API usually. The two main things are you need to authenticate to the API, so you need to prove it that you have access to this API and you're allowed to do stuff. This is using an API token, which I've kind of redacted here. I put it in an environment variable to make these examples work. So this is like my like secret token that I'm gonna send them. And then you also sometimes, in this case we're not doing that, but you sometimes want to send extra information about like to the API about like what, like the parameters for what you want to get, right? You're like I only want data before 2016 or something like that. We're gonna see that in a second. So let's just run this and see what it looks like. So if we curl this, we get the response back, and it turns out that this is an XML API, it looks like. So here you can see like this is some XML thing, and then there's like a post tag, and then there's a bunch of posts inside it. And I think that at this point, for some reason, I had Pinboard set up to like only like just have a bunch of tweets that I favorited. I don't know why. So I guess that's what's in here. But the point is that it's just some XML, and that now I know that that's what this API is returning, and maybe I could write some code to parse that XML, or I could see if someone like already wrote a client library to do it for me, if I don't feel like it. So let's look at another API. The other thing that I wanted to say is actually that I think it's important to understand like what this incantation corresponds to as a request. So in this case, what that corresponds to is you're sending a GET request, and you're sending this like secret token as part of the URL. So we're just doing like question mark auth token equals like my username : this token. And that's how we're authenticating to this API. And the other ones are going to be different. So let's look at Gumroad now. So this is saying, let's go to this API. It's passing an access token. It's sending a GET request, and it's saying I only want sales, I guess, before September 2017. So here we can see we're getting back a bunch of JSON, but that's kind of ugly. What I like to do if I get JSON back from an API is I like to pipe it to JQ, which is this really great JSON parsing tool that actually has its whole own programming language. So let's look at that really fast. So if we pipe this to JQ, then it looks a lot prettier, which is great. And we can see some different parts of the response here. I can see that there's like a refer, so I can go grep for the refer field. And this is where I start to really like using curl. There's this extra nonsense here that just like this progress indicator from curl. We can make that go away with -s, which I think I'll do because it's a little annoying. So now that's gone, and now it's just showing me the refer for like all of these sales, like where people were coming from, which is, yeah. Back in 2017, I wrote this blog post about like a tracing zine, I guess, that people downloaded. Yeah. Okay. And here the request that's being sent is a little different. So with Pinboard, the request that was being sent was the authentication token was part of the GET, right? It was part of the URL. And here our access token is part of the request body. So instead the request, like here we said like -d access token equals Gumroad token, and then another like -d before equals whatever. And what it's done is it's done a couple of things, which is it's set the request body to like access token equals redacted ampersand before equals 2017-0903. So it's kind of like put these things two together and put an ampersand in between them, and that's basically like a URL encoded body. It's pretty common, and it's also a GET request. This is a little bit weird, and like if you're familiar with HTTP, you might think like you've made a mistake, Julia. Like this is wrong, because usually when you send a request to an API with a body, it's going to be a POST request. But it turns out that the way Gumroad has set up their API, it's a GET request. It has to be a GET request. And if you send them a POST request, it won't work, which is fine, right? That's how their API works. That's okay, and we can just send a request that they expect to their API with curl. So let's look at one more different API, which is Stripe. And I should say that like both of these examples, the way that I wrote this curl incantation is I didn't like invent it myself. Like I didn't just like write it down from my brain. What I did is I went to their website and I did like. They had an example and I copied and pasted it, and then I like put it in my terminal, and then I played around with it until I got the right thing. So I think in my case for the Gumroad one, I needed to add this like -d before equals because I wanted like only records before this date. And I just kind of like pattern matched on like, oh, I see. Well, if I passed one thing, like the access token with like -d access token equals, then probably if I want something before, then it's like -d before equals. So Stripe has a similar thing. You can see it's also using these -d things to set the request body to have some parameters where you're like, hey, I want to create this charge. It's like for $9.99. It's in USD. Here's the email address. Here I'm not redacting the key because I think this is just like a test key I found on their website. It's not super secret, even though SK does stand for secret key. So this really is a secret key. Just this one itself doesn't happen to be secret, because I found it on in the public docs. And here you can see this is sending a POST request, which is more normal if you're sending a request body. And this is more like the Gumroad example, right? Where you have like amount equals 999 ampersand currency equals USD ampersand blah blah blah. That format is called application/xwww form URL encoded, which you can see in the content type there. Some other APIs will let you send JSON, and for those you need to set the content type. If you're going to send JSON, you need to set the content type to application/JSON. Otherwise, it doesn't work, and that's a common mistake that people sometimes make when they're when they're making post requests is they'll set the wrong content type. The other interesting thing about what curl is doing in this request is there's this -u flag to curl, which is set to like sk test blah blah blah. Because before, you remember with Gumroad, this access token was part of the post body, right? And that's not what's going on with Stripe. There's no access token in here in the body, and instead the access token is in this thing called the authorization header. And so basically what curl does if you say like -u something is it'll like base64 encode this thing and it'll put it into the authorization header. So this isn't encrypted or anything, but it is base64 encoded. And but this is sensitive information. It's basically like a password. And a lot of APIs will use the authorization header to authenticate you. And I think that's kind of like the tricky thing about some of these HTTP APIs is that like they all use like different methods for authentication. They all like expect you to send like the body in maybe a different way. Though a lot of them do use JSON. So you always need to like look at the docs and figure out how to use it. And especially if you're writing your own client, like it's useful to be able to understand like what some of these different headers mean, and how they go together. So that's it for APIs. I have this gist where I have all these examples, and I put some of my favorite command line arguments to curl there too, if you want to look at them later. The other like one thing I would say you can do is if, let's say you're on a website that you're trying to scrape, and you're like, oh man, I really wish I knew. This is a silly example because it's pretty simple. But let's say you really wish you knew like how it made this request to get this like cat picture, right? I'm gonna zoom in a tiny bit. What you can do is you can go to the network tab in your developer tools. This works in either Firefox or Chrome. And if you right click on something that your browser requested, you can go to copy and then get copy as curl. Okay, there we go. So what copy as curl will do is it'll copy the exact specific request your browser made so that you can make it yourself. And the reason this is useful is like, for example, let's say you've logged into a site and you have like some secret login cookie that you need to get the web page. Copy as curl will let you copy all those cookies so you get the exact same response that your browser got. And it'll also make sure that like if it got a compressed response, it'll send the request for like something compressed. It'll send the referrer header. So if you're trying to like reverse engineer and like some kind of thing that is happening on a website, like if you're trying to reverse engineer like an undocumented API, copy as curl is a really great way to get started and start to see like what requests your browser is making, because you can make all those requests too. Like there's no secret about like what your browser is doing, you know. And like usually if I'm trying to like reverse engineer something with copy as curl, I'll start deleting headers pretty fast, right? Like I kind of know a lot of them aren't important, and I'll usually just keep things like the cookie header. The accept language header is kind of fun. If you change the accept language header to a different language, sometimes you'll get the website in a different language, which is fun. Like on Twitter, if you set like accept language like ES, you'll get Twitter in Spanish. But a lot of these don't do too much. And so if you're trying to reverse engineer, you can kind of ignore them and play around. So that's all I have to say about my love for curl. I do think that this copy as curl thing is a good example of like why having curl as part of your toolbox is useful, right? Because HTTP is really great, but this does not say like copy as HTTP. It says copy as curl, right? Because it's kind of the standard. Yeah. So hopefully that helps you use curl. Thanks for watching.